Hi guys, today we're going to begin our first lesson, Introduction to Matter. We have all heard of the word matter, but what exactly is matter? Matter is anything that has mass and takes up space. For most common objects that we deal with every day, it is fairly simple to demonstrate that they have mass and take up space. Air and all other gases are invisible to the eye, have very small masses compared to equal amounts of solids and liquids. Mass is a measure of the amount of matter that makes up an object. For example, you are made of matter, but you are made up of more matter than objects around you, so you have a greater mass. The mass of an object does not change when the object's location changes. The mass of an object changes only when the amount of matter that makes up the object changes. This is important so we understand the difference between mass and weight. Usually people confuse these two and think that they are the same. However, they're not. Weight is a measure of the gravitational force of an object. Gravitational force keeps objects on Earth from floating into space. The gravitational force between an object and Earth depends partly on the object's mass. The greater the mass of an object, the greater the gravitational force on the object, and the greater the object's weight. But an object's weight can change depending on the object's location. An object would weigh less on the moon than it does on Earth, because the moon has less mass and therefore less gravitational force, about 1/6 of the gravitational force of the Earth. When we measure mass and weight, we can think of comparing two objects, like a sponge and a brick. Because the brick has a greater mass than the sponge, a greater gravitational force acts on the brick than on the sponge. As a result, the brick weighs more than the sponge. The SI unit of mass is the kilogram. We can also express mass in grams and milligrams. These units can be used to express the mass of any object. Weight is a measure of the gravitational force. The SI unit of force is the Newton. 1 Newton is equal to the weight on Earth of an object whose mass is about 100 grams. All matter takes up space. The amount of space that an object takes up or occupies is known as the object's volume. Your fingers, the continent of Africa, and a cloud have volume. And because these things have volume, they cannot occupy the same space at the same time. Even the tiniest piece of dust takes up space. Another piece of dust cannot fit into the space without somehow bumping the first piece out of the way. When we talk about volume, we usually concentrate on liquid volume. Lake Nicaragua, the largest lake of Nicaragua, has a volume of about 2 trillion liters of water. Think of a 1.5 liter bottle of water. The water in Lake Nicaragua could fill more than 32 trillion 1.5 liter bottles. On a smaller scale, a canned drink, like a Coke, has a volume of only 0.355 liters, which is about 1/3 of a liter. You can estimate the volume of a can by using a large measuring cup to measure the amount of liquid that a full can holds. The liter, symbolized by a capital L, is the SI unit for volume. Often, small volumes of liquid are expressed in milliliters. Remember that 1 liter equals 1,000 milliliters. Any volume of liquid, from 1 drop of rain to a bottle of water to an ocean, can be expressed in liters or milliliters. When we measure the volume of liquids, we usually in class use a graduated cylinder instead of a measuring cup. Graduated cylinders are used to measure liquid volume when we need to be accurate. The surface of any liquid in any container is usually curved. We do not notice this in large containers but it is obvious in small containers like cylinders. The curve at the surface of a liquid is called the meniscus. For most liquids, including water, volume should be measured from the lowest point of the meniscus. When we determine the volume of a regularly shaped solid object like a cube, we usually express volume in cubic units. The word cubic means having 3 dimensions. In science, cubic meters and cubic centimeters are the units most often used for the volume of solid things. The 3 in these unit symbols shows that the 3 quantities or dimensions were multiplied to get the final result. You can use formulas to find the volume of regularly shaped objects. For example, to find the volume of a cube or another rectangular object, use the length, width, and height of the object and multiply them. To determine the volume of an irregularly shaped solid object, what we usually do is determine the volume by displacing water. What we do is we place the solid object in a container filled with water, and we observe the displacement, the pushing of the water done by the object. The volume of water displaced by the object is equal to the object's volume. Because 1 milliliter is equal to 1 cubic centimeter, you can give the volume of water displaced by the object in cubic centimeters. Volumes of liquids can be given in cubic units, but volumes of solids should not be given in liters or milliliters. Using displacement to find the volume of an object that floats is more difficult. In order to do this, you must use another object to hold the floating object under water. Then, you must subtract the volume of the object holding the floating object. Displacement cannot be used to find the volume of something that dissolves in water. Finally, today we're going to talk about density. Density is a physical property that describes the relationship between mass and volume. Density is the amount of matter in a given space or volume. A golf ball and a tennis ball have similar volumes, but a golf ball has more mass than a table tennis ball does. So the golf ball has a greater density than the table tennis. To find the object's density, we first must determine its mass and volume. Then, we take the mass and we divide it by the volume, given the formula density equals mass over volume. Units for density consist of a mass unit divided by a volume unit. The density units most often used are grams per cubic centimeter for solids and grams per milliliter for liquids. The density of a given substance remains the same no matter how much of the substance you have. That is, the density of 1 cubic centimeter of a substance is equal to the density of 1 cubic kilometer of that substance.